Okay, we're gonna record. Why is 13 a magic number for you? It's
Um,
bad luck
Many
in
people like you think that number 13 is bad luck, but it has never been bad luck to me. So I kind of took that number as one of my favorite numbers. If you actually look at my t-shirt, which is from some old flag football team that I played in when we went to play in Europe, you'll actually see, probably, I can't see myself, but it has my name and the number 13. Can you see it?
Hmm.
So, yeah. So, week 13 for me looks like a good week. And before we start, usually at the beginning of each presentation, we have a Kevin and Hobbes comic strip, thanks to Vicky, who's a big fan. And this time she sent me three versions, which are all one way or another connected to summer, saying that we should celebrate the end of summer this way. But the interesting thing is that one of those strips that I selected, it seems to me, is actually very much connected to coding, to programming. And I wanted to show you this strip and see whether you can figure out what I saw in that strip that Vicky didn't see. So maybe someone else can look at it and say why I think that it has something to do with programming. So here is the strip. It actually has, just give me a sec. So Kevin is chasing, I don't know what this is. This is
It's a
like a
fly.
fly. It's a fly, and he catches the fly, and he sort of releases the fly, out of the house, but three more flies come in. But he's sort of happy about it. So the question is, do you see, like, this is actually metaphorically a very programming thingy. There you go. So Mansi understood it immediately. This is exactly what happens in programming. So you catch a bug, you sort of deal with that bug, and you sort of think, okay, cool, everything's done, everything's going to work perfect. And then it turns out that, you introduce three more bugs or 10 more bugs or whatever. So that's the reason why I like this one. Yeah, yeah. So this is how you would learn that the person is a programmer. Okay, cool. So let's start with today's session. And as usual, we need 3 seconds of time for this slide. So 3, 2, 1. I hope Cameron is okay with this. As usual, we still have both Emma and Dieter holding office hours at the same time of the same day. So Emma is on Thursdays from 8 to 9 a.m. Pacific time, and Dieter is on Wednesdays from 8 to 9 p.m. Pacific time. So feel free to drop in with any questions that you might have. And the schedule that we have for now looks like this. Today, week 13, we're going to talk about nested structures. And week 14 is going to be full of different things. So we're going to talk a bit about tuples or tuples, however you pronounce it, depending on where you are in the world, I would guess. We would talk a bit about sorting, about lambda functions, and list comprehensions. So I hope we will be able to squeeze in all four of these things into one week. In week 15, we're going to do a project which is a bit of a clone of Google, which is it called Bajillion or something, Vicky? I don't remember. I think it's called
It's a
Bajillion.
bajillion search engine.
Yeah, so
It's
it's
the
it's
biggest
sort of
one.
a search engine. And on week 16 and possibly week 17 after that, we're going to talk about object-oriented programming, because I'm quite certain that one week will not be enough to talk about this. Like OOP is a very, very big and very different topic, so we'll need to spend some more time on it. And as usual, Vicky has some prizes for us and a quiz for us. And with this specific quiz, I still have no idea what the correct answer is. So, though Vicky is shaming me and saying, I thought you were smart, Alex, and you don't even know the answer to this one, which is probably supposed to mean that this is supposed to be easy. But let's see
It's
whether
moderate.
it is or not. Okay, moderate. But Vicky thinks I'm more than moderate, but it turns out I'm not. So as usual, it's going to be an image of a location. And this time it's easy because you only need to write two things. You know, last time we had to write four. This time it's only two. So you need to write the name of the location and the country in which this location is located in the chat.
And I will just say, I've decided since so many people seems to want a Code in Place t-shirt, I will continue to sponsor a Code in Place t-shirt even though I don't have free shipping anymore. Thank you to Jerome Powell of the Feds and Larry Ellison of Oracle. I did make some slight windfalls on my stocks in the last 3 weeks. So, until the end of this course, if you want to try to win a Code in Place t-shirt, come to Zoom and try to answer these questions, and maybe you too will win a Code in Place t-shirt.
So yeah, thank you, Vicky. Another Code in Place t-shirt is up for grabs. Whoever is the first person to write
30
this
seconds.
in the chat, both the name and the country.
Alex, at the 15-second mark, you can give the hint if you want.
Oh, I thought we'd do that at the 30-second mark when we're
Well, I
sure
mean,
that
and then it would drag on.
if no one writes, then I'll give the hint. We
I
have a
thought this
hint.
is actually very easy, but
Yes.
maybe not.
Sorry, hold on. You said it's very moderate.
Well, I mean, originally I thought it was very easy, but since you said you had no idea,
No,
then
and
I
I
changed.
don't see. Okay, we have Waimea Canyon State Park, USA. I have this answer in the chat.
That
Okay, I think
actually
it's
is the correct answer.
okay. It is the correct answer. Okay, I have no idea why you would expect me to know that. I have no clue what that place is.
Well,
But
you
the
heard
hint.
well, I would have taken Kauai, Hawaii. So
Okay,
So yeah, and so this place is one of the Hawaii Islands. It's called Kauai. It's the greenest of the Hawaii Islands. And what's unique about this place is there are more chickens on the island than humans, and nearly as many pigs as humans. On this island, and I just wanted to show one picture, which I sent to Alex, but he
and I
did.
forgot to put it in, of course.
Um, it's okay. So, we were there right before COVID in 2019 over Christmas, and there was a huge storm over Christmas that blew out all the power lines. And so, even in the hotel that we were staying in, there was no power for 24 hours. But what had happened was there was also a helicopter crash by the Nepali coast of Kauai. And so that news actually made it back to the mainland. And so it was apparently on the internet. And that the only info they had was there were like 6 or 8 passengers, and then there was like a family on that helicopter. And so our like friends and family like freaked out because they couldn't get hold of us because our cell phones and computers were not working. So they thought we were um, involved in that helicopter crash. But realistically, fortunately, we were fine. And then we would never be like dumb enough to go on a helicopter anywhere. So yeah, that is Waimea Canyon, Kauai, very beautiful place. Nick, you'd
And
already won a shirt, right? Do you want another one? I'm happy to get you another one.
more shorts,
Uh,
more.
No, don't worry
Uh,
about it. But thanks for offering. The last
Okay.
win wasn't really legitimate anyway.
If you want to donate it to a student, I'll let you um, pick a
me,
student.
says Cammy, me.
Mm,
That's what you get when you have a camera on. You can actually, I can see you ask for a t-shirt. And
does
I
Alex
love
have
what
one? You
Flora
could
wrote,
donate one to
saying these
him.
tests
Oh,
made me realize that my anxiety around my geographic ignorance is absolutely legitimate. Yes, they are. I also have, it seems total geographic ignorance. The only difference is probably that I have no anxiety whatsoever about it. I don't care. But yeah, Vicky is making us all look like fools and
oh,
probably
I mean,
enjoying it in the process.
oh, okay.
Oh, of course not.
Um,
Of course not.
the one next week is hard, but the one after that will be easy. Okay.
Right. Or not. We'll
I
see.
promise the one after next week, would be easy.
Right. So, the plan for today, we're going to talk about nested structures, and as usual, we're going to do assignments in breakout rooms if you want to. And then we'll discuss solutions together in the main room. Once again, these minutes are, just guesswork. We'll try to. I'll probably spend about 20 minutes talking about nested structures, and we'll split the time in half between breakout rooms and solutions. So you're saying we can discuss it later, but I was asking if Alex has one. No, I don't. I don't. I'd rather give it to Kemi. So yeah. So let's talk about nested structures. First, before we start actually talking about nested structures, let's discuss what a nested structure is, because we actually encountered one type of nested structures, and that's, can someone remind me what nested structures we talked about? I love the dead silence in the air. Anything nested that we've discussed? Anything
List.
at all? List within list. Thank you, Mansi. We did. So nested lists. And when we talk about nested structures, much like a nested list, which is a list of lists, a nested structure is a data structure that contains other data structures as its elements. And the most commonly used data structures in general, and more specifically nested structures, are lists and dictionaries. So you could have a list that has a dictionary that has a list, or a dictionary that has another dictionary that has lists, or a list that has dictionaries with lists with dictionaries. So whichever way you spin it, usually it's a combination of lists and dictionaries inside one another. And to make this more specific, I would propose to look at a simple smartphone contact list as an example. And it's really going to be very simple because in reality, there is a lot more data stored in contact lists than what I'm going to have here, but we can sort of think through this. So let's say we have actually a contact list as a data structure. And the name contact list actually already sort of gives you a hint what the top level structure is going to be, because it's going to be a list. So it's going to be a list of elements following one another. Index 0, index 1, index 2, etc., etc. So there is a specific order in this contact list. And this contact list is going to contain elements which are basically the contacts. So we're going to have an indeterminate amount of contacts in there. Some people have, I don't know, 2 contacts in their phones, and some people have like thousands of contacts in their phones. So it's going to have a nested structure, which is going to be a contact, and the number of these contacts is unlimited. So it's a list. It can have as many contacts as you might want. So if we look at the contact itself, the question becomes what data type would the contact be? And in our case, I would say that a contact is a good candidate for a dictionary because it's going to contain various data like the first name of your contact, the last name of your contact, the phone numbers that your contact has, etc., etc. It could have the email address, it could have, where the person works, it could have the name, like I said, yeah, the name of the company, or whatever else you have in your contact list. I don't know, maybe social media profiles, whatever. And first name is obviously going to be a string. So you would have first name as the key in this dictionary and the actual name itself, the value. And you have last name as the key and the actual last name as the value. And then you have phone numbers because people usually have several phone numbers. Well, some people have only one, but that's a rare case. So usually you have maybe, your home numbers. Some people still have, so you would have cell phone numbers. Some people have several cell phones from different providers, etc., etc. So you would actually have a list of phone numbers. So phone numbers would be a element which would be a list containing actual phone numbers inside, and you would have phone number 1, you would have phone number 2, etc., etc. It could be any number of phone numbers. So this is a very simple a simple example of a nested structure. So once again, you have a list. This list contains dictionaries. Each dictionary contains, strings for first name, strings for last name, and a list of phone numbers as one of its key value pairs. And the phone numbers themselves will usually be strings as well, because there is no sense in actually storing them as integers, for instance. Let me take a quick look in the chat. I think it has, the questions there or the discussion there has nothing to do with what I'm talking about right now. It's probably about Hawaii, someone will probably speak up if there are questions and they're related to what I'm discussing right now. So
yeah, we're moderating the chat. Don't worry.
Okay, good. So if we take this structure and actually try turning it into code, the question is, how would we code this? So let's try visualizing this contact list in code. So we would have a variable which would be called contact underscore list, which would initially, let's say it's an empty list. But this empty list is supposed to have contacts inside. And these contacts, as we've discussed, are going to be dictionaries. So it's going to be some number of dictionary contacts. So that's why I put the ellipsis here. We don't know how many there are. And for each of these contacts, we would have key value pairs that actually describe the contact. So for instance, if you take me, you would have the key first name, you would have Alexander, you would have the key last name, that would be Belyakov, you would have the key phone numbers, and this would be a list as well. So at the moment it's an empty list, but we're actually going to store my phone numbers in there. So for instance, I could have 2 phone numbers, and it was funny when Vicky saw this slide and she said, "What, are you gonna share your phone numbers like on YouTube? What, are you crazy?" And I'm saying like, okay, my phone number is not 555 or so. It's cool. But basically, yeah, this is like my Russian number and this is like my Armenian number. I use both, so I have 2 numbers. Some people might have less, some people might have more. Probably a contact with no phone numbers is pretty useless in a contact list, but it's a definite possibility as well. And each contact would look like this. This is once again a very simplistic model, but it would look like this. Usually, like this is creating a very specific contact list in your code, but usually you do not create contacts in your code. That would be weird, right? Like, why would your code contain someone's contacts? That's should be actually, what the user is doing. The user should be adding information to the contact list. So let's talk about adding data to the contact list. How would we actually do that? So initially, we would have an empty contact list. So your application would have an empty list. It would probably read from an empty file into an empty list. And then if you'd want to add something, you would create a contact. This would probably be done using input, but in the end, you would have a contact dictionary which has all the information. And then you would say contact list dot append new contact. And this variable, this contact, would actually be appended to the end of the list, which you currently have. And you can do this over and over again, and your list would grow and grow and grow. And at some point, you would actually be able, for instance, to sort your list if you decide that you want it to be sorted by first name or by last name or by phone number or by country or by email address, whatever. And your application would have the ability to actually sort how this is presented on the person's screen, be it a mobile phone or computer or whatever. You would also need the ability to edit this contact information in your nested structure. So the way you would do it, you would actually use an index to access a very specific contact, and then you would use the key for whatever you want. So let's say you think that Alexander Belyakov, is too formal. Everyone calls me Alex, so you want to change my name to Alex. You go like under index 0, which is the first entry, under the key first name. Now let's store the value Alex, the string Alex. So now you changed my name. Or for instance, you decided to add a new number. So this would be somewhere in the Stanford area, I suppose. And you could actually, using the same index 0 and the key phone numbers, type dot append new number. And this number would be added as the third number in my list of phone numbers. So this is the way you would actually edit contact information inside your program. If I wanted to delete, for instance, if I ever decided to get rid of my Russian number and delete it, I could, for instance, use pop0. So if you remember, pop is a method which accepts an index and it deletes the entry with this index. So my Russian phone number was the first one. So at index 0, I would be able to delete it, and so on and so forth. You can, manipulate the data that you have inside your contact list in whatever way you want as a programmer. So I think this is it in terms of, theory. There's not much else to say because there is nothing new in this. So the thing that I just took you through, you should already be familiar with it because, once again, we've already done nested lists, and the logic here is very similar to nested lists. The only difference being that with nested lists, you have, indices following indices. And here you could have whatever you want. You could have keys, indices, keys, in any order that that your data structure, your nested data structure requires. So that's the only difference, but otherwise the logic is very similar. So before we go into the assignments that we have for today, I would love to answer any questions, thoughts, or, whatever. Anything you want to say, right, please do.
Alex, I'm gonna start because maybe I'm just kind of not very awake this morning. Can you go back the one slide? Okay. So if you have a list of lists, right? Those two brackets would be indices, right?
Yes.
Okay. So here, the second bracket is first name. And so first name is literally the key, right?
Yes.
Okay. Okay.
So
Okay.
it's the key of the dictionary which is stored at index 0 in our
Zero,
list.
right. Okay. Okay. And then when you have the contact list, similarly, phone number is the key.
Yes.
Okay.
So it's the key that stores the list as a value, and that list contains my phone numbers, which are strings. So we can go back to look. So here's the way it looks. So you have the even let me go here. So you see contact list is a list, and inside we have this dictionary,
Dictionary. Okay.
which is my contact. And inside here you have one, two, three keys. The first two keys just contain strings, my first name, my last name. But the last key has a list as its value. So that's another nested structure. So it's triple nested now. And it has my two phone numbers. And
Okay.
if I want to add another one, I would have to go contact list 0, index 0, key phone numbers, dot append whatever new number I want to append.
Okay.
And
So here's my question. Can you go to the next slide?
this one?
No, the one after. Yeah.
Mhm.
Okay. Okay. So basically, in your brackets, is it fair to say you could either have a positional indices, which is a number, or you could have the actual key?
I'm not sure why you used the word actual here, but the idea is correct that depending on the structure of your structure, sorry for the, um, you would either have indices or keys depending on where you're using lists and where you're using
Okay.
dictionaries.
Right. So I believe, okay, if I recall correctly, when we learned about dictionaries, there is a way to loop over dictionaries, not by the keys themselves, but by their position as well, right?
It does dictionaries like dictionary key value pairs do not have positions per se.
Well, I mean, there's that enumerate function.
Yeah, but the enumerate function simply provides you with a number. It does not, this number does not signify an actual position.
Okay. Okay. Okay.
So those are sort of like two processes which are parallel. They are not actually connected.
Okay. And so I guess the answer to my question would be no. And so if you have a dictionary, okay,
Mhm.
if you have a dictionary, there's no way you could substitute that actual key by a number that references its position, like it's the first key, the second key, or
No,
the
no,
third
you're
key.
absolutely
Okay.
correct. You
Okay.
cannot do that. No, there is no such thing in a dictionary. The only thing you could actually do, you could use integers as keys, and then you would have sort of like indices.
Okay, if you were to use integers as keys, though,
Mhm.
okay, when you write that integer in your brackets, I think, would you still need the quotes around them? Because
You
if
can
you're,
use an integer without quotes. You can use a string with quotes. You can use any immutable data type, and both
got it. Yeah,
integers and
okay,
strings are immutable. So
gotcha.
it's your choice.
Okay.
The only thing to remember, remember when we talked about JSON, JSON does not store integers. So if you were to save a dictionary that has integers as keys into a JSON file and then read back from the JSON file, you would actually get them as strings.
Yeah.
This is important to remember because otherwise you would get erroneous keys and you would go like, why? I had integers in there, but they're not there anymore. I think that's the only thing that JSON actually changes. Okay, so good questions. Any other questions on the subject? or shall we go into the problems that we're going to solve today? I constantly keep forgetting. Do we solve problems one by one? So we do the first problem, then the solution, then the second one, then the solution, right? Is that the way we're doing it? I think.
It's up to you.
I
Dealer's
think
choice.
that would be easier. That would probably be easier. So let's just talk about the first one. And the first assignment that we're going to do today is called the network assignment. And what we're asked to do is to actually implement a function which is called find missing friends, which sounds very sad. So this function takes in the name of a file. This file contains JSON representation of a network of friends. So let's say you have Facebook. On Facebook, you have a network of friends, and this JSON file contains that network. So who your friends are. And what the function has to do after taking in that information, it has to print out, this is important, it doesn't return anything. It actually prints out the names of friends who are actually mentioned as connections, but are not actually present in the JSON data as dictionary keys. So for instance, you have a friend with whatever name, but it's the name itself is not a key in the dictionary. So those are the names that you have to print out and say, these are the missing friends. We don't have information on these friends in our JSON representation. And it's a lot easier to look at this as an example, because it sounds like a mouthful when you just read the assignment itself. So in the JSON file that you're going to have in this problem, which is called, if I remember correctly, data.json, you are going to have a representation of a dictionary, which is going to have a single key, which is called network. And from my perspective, this is a very bad way of storing. I mean, if you have only a single key in your dictionary, what's the purpose of that key? But I think this is done for educational purposes, so that you understand how nested structures work. So you have to work with the fact that you have a single key, which is called network, and the value stored under that key is another dictionary. So we have our first nested dictionary, and inside this dictionary you will have a number of keys which are going to be names of people. So for instance, in this specific example, I have myself, Alex, and I have Vicky. These are two keys, two people in the network that we have. And the values are going to be the list of friends that I have and the list of friends that Vicky has. Just give me a second, please. I need to help out my wife. Okay, so once again, we see that we have another level of nestedness, so to say. We have one dictionary that has another dictionary, and that dictionary has even more dictionaries as values. So let's look first at Alex. Let's say Alex has some friends, which is debatable, but So I'm actually going to have the key friends, and this key friends will actually have a list as a value. So we have a dictionary which has a dictionary which has a dictionary which has a list. So this is the fourth level of nestedness. And inside this list, I'm going to have a list of names of who my friends are. So, and the same would apply to Vicky. Vicky would also have a list of friends, which would be dictionaries as well. So this is the fifth level. We have a dictionary of dictionaries of dictionaries of lists of dictionaries. And each of these dictionaries is actually a contact. Remember the contact that we had in my example with the smartphone application. So here it's very similar. This dictionary would have several key value pairs which actually describe the person. In our case, for instance, let's take a look. Alex has a couple of friends. So the name of the first friend is Vicky, and the second key which we're using is called years friends. So how long we've been friends. We've actually debated this with Vicky. She said we haven't been friends for 2 years. It's like barely a year and a half.
I'm not
And I'm
even sure
saying
we're
I'm rounding
friends.
up. I'm rounding up. So Vicky, we've been friends sort of for a couple of years. And then I have another friend whose name is Vladimir. So he has been my friend for 25 years, back from 2000 when he came into power in Russia. So since that time, whether I like it or not, I have to have friend Vladimir. And that's the way it works. And then let's take a look at Vicky. So Vicky also has a couple of friends. Well, no, Vicky has a lot more friends than me, but for this example, we only have a couple. So the first name is it's mutual. The first guy names is Alex. That's me. Years friends also too, which is logical. That's the way it usually works. And then Vicky has a second friend. His name is Donald. He's been around since 2017, so that's about 8 years. Not as much, as Vladimir. Hasn't done as much as Vladimir, but yeah, maybe still ahead of him. And if we run our function using this data, it should give us two names which are listed as friends, so either my friends or Vicky's friends, but are not actually present in this data representation as entries. So in our case, I have Vicky as a friend, and Vicky is present as she's represented in this dictionary, so it's okay. But then I have Vladimir, and obviously I have no information on Vladimir because no one is supposed to have any information on Vladimir. And the same applies to Vicky. Vicky has Alex, so Alex is in this JSON file, but Donald is nowhere near because the Secret Service keeps, very close tabs on what's known about this guy. So in the end, this function would have to print out two names. It would have to print out Vladimir, it would have to print out Donald as the two missing friends. Let's call them missing friends, quote unquote. I think that's it with the network problem. So before we go into breakout rooms to actually work on this, and I'll remind you that as usual, we will have three different opportunities, three different options. You could either go into the room for people who've already finished this and just discuss, how you've done it and how you could have done it better, maybe. The second room would be for people who have not attempted it at all or did attempt it but did not manage to finish it. And the third one is for those of you who just want to do it yourself privately without any friends in your network. So in this case, you could stay in the main room. But before we do that, I would love to answer any questions that you might have on this specific problem or what we've discussed previously. Any questions?
Can I just make a quick announcement? Because Emma is not here today, if you're going to stay in the main room, you will not have an SL because I basically made one room for people who've done the problem and two rooms for people who are still working on the problem. And there's only three of us. And so I figured each of us could take one of those rooms. And so if you want to be friendless or feel antisocial, feel free to stay in the main room. No one's gonna bother you, but you also won't have access to an SL to ask questions. So
All right. Thank you for the clarification. Any questions, or is everything clear and we can jump into the discussion and the actual coding? I see we have at this moment we have like an hour, 20 minutes to do everything. So code solutions. So that would give us like what?
15 minutes in the
15
breakout.
minutes. Okay. Yeah, let's try. We'll see whether we actually have enough people to be split into work in progress 1 and 2, and then decide from there. Maybe, someone will stay in the main room.
Yeah, I mean, I'm happy to stay in the main room.
So which one do Alex and I go?
You guys can
Flip.
can duke it out amongst yourselves.
I
Okay.
I don't mind going into completed.
Okay, you'll do that. I'll do
All
the
right.
work in
Okay.
progress
So yeah, I see the
You can
question
go
one.
to a
for
work in
says.
progress one because there's nobody in
Okay.
work in progress two.
Okay.
And so if there's no one in work in progress two, I'll just stay in the main room too.
Okay.
Because I'm all about minimizing work.
So Flora, which room do you want to go to? The completed or the work in progress? Completed. Let me try actually assigning you there. Yeah, there you go. Ah, no, you still have to join. Um, possibly did you get a pop-up window saying that? Yeah, there we go. Okay, Flora joined. Yeah, I think we have two
Marnie,
rooms.
Cami, Emmy, Lillian, you, Momina, you all want to stay in this main room?
I want to join one of the groups, but I can't find where to do that.
Well, okay, I can assign you. You want to go to work in progress or you want to go to completed?
Uh, Either way, but I need someone to help me code.
Yeah, yeah,
So
yeah. Do you want to go to Alex's room?
yeah,
Okay, put that. Okay, anyone else that wants to join a room but can't, I can assign them. Okay. All right. Okay. Lillian, Momina, Emmy, do you guys have any questions? Um, don't be afraid to just holler. I'm here.
Hi. Um,
We start the recording. Okay.
Okay. So Dieter, tell me how did it go in the how far did you manage to go before we were brought back abruptly into the main room?
We actually got all the way done.
Okay, cool. That's
Uh,
excellent.
it was mostly one participant that contributed most of it, so I hope the others could follow along. But
Okay.
yeah, we solved it to the point where we got multiples printed, and then we took care of that.
Okay, that's good to hear. But let's maybe quickly take a look at this problem. So let me share my screen because, like always, there are 1,001 way to do this problem, and I've only seen two, and they were quite different. So once again, we need to write a function which is called find missing friends, which has to print out all of the names that are not present in the dictionary itself, but are mentioned by other people as friends. So at the beginning, we already have two lines which take this data file, which is in JSON format, and actually turns it into a dictionary. So we already have a dictionary which is called input dict, which has all of this information. So we don't have to worry about the way this would be loaded. But there is one thing. Remember that I told you that this entire dictionary has only one single key, which is network, and all the useful information is actually inside this key, so the value to this key. So in order not to have this huge number of structures within structures within structures, it's a good idea to immediately get rid of this key. You don't need it. And the fastest way to do it is actually here, where you use load. You actually get the dictionary, and then immediately here you can add network as the key. And then inside input dict, you would have everything that's inside. So starting with Kval here and going Emily, so long and so forth. So I'm actually getting rid of this extra level, which I don't need. It does not have any value. So now that we have this input dictionary, we need basically to figure out two things. We need to figure out who the people in this dictionary are, and who are the people that people are mentioning as their friends. And then you have to compare them and see, if it's listed in one but not listed, or in the other, or the other way around, not listed in the first one but listed in the second one. Those are the people that we want to print out. Yeah, they're mentioned, they're not actually, we don't have any information on them. So this sounds like a good way to use a for loop, because we can actually go through the values here to get all of the names. And then for each of those names, we would actually need to go inside the dictionary, go through the friends, and if a friend is not listed, we would need to print him out. But the thing that we need to bear in mind, if, for instance, several people have the same friend listed, we do not want that friend to be printed out several times in case that friend, is missing. We just want him to be printed one time. So the way this could be done, we could actually create two lists. So the first list I would call, someone called it names. You could call it people. You could have whatever you want, but let's call it names. Let's start with an empty list. And what I would do, I would go for name in input dictionary, names append name. So this way I would create a list of all the names, like Kavel, and then Emily, and then Vanu, and Maika, Venki. Those are some interesting names. I'm not sure how to pronounce half of them, but okay. Maybe they're Hawaiian, I don't know. And I would have that list, so we can actually quickly check this. Let's say print names, and we'll see what we have as the list. And it does not print anything because I actually would have to run main. I don't have a main here. So I would go find missing friends, and the name of the file is data.json. Let's do this one more time. So here, as you can see, we have Kavel, Emily, Vanu, Maika, Venki, and so on and so forth. We have like an entire list of names who are in the dictionary. So the second one, which we need to get, is the list of friends, which I will also start with as an empty list. Here it gets a bit trickier, but here the previous list will actually help us, because we will go, although would we actually need it? I don't think we would actually need it. I would still go, I think this is the way we could do it. We could actually have two lists at once. Why would we need to iterate over this the second time, where we can actually iterate over this once? We would have two lists, both names and friends, and when I iterate over the keys in the dictionary, I would append the name, and then for each of those names, I would go in. So I would go for friend in, and this is the most difficult part. So I would need, please correct me if you see me making a mistake. So I would go input dict, then as the key, I would need to take the name. So for instance, I go, I have this dictionary, and I go into name, which first one is Kavel, and then I would need to go into friends like this, and I would be iterating over these sub-dictionaries. And for each of these sub-dictionaries, I would be interested in the name. So the way I would do this is say friends append friend name. But what this would give us, this would give us what I'm looking for, but there is one sort of logical error in here. Can someone point out to me what the error here is? What would I get wrong in this specific So I'm basically going over each friend in a list of friends and then appending, whatever is listed here. So I would,
Well, I mean, you're not checking if um if the friend name is in your original um input dict as a key. Um
at the moment I'm not, yes, because I am at the moment I'm putting together two different lists. I'm having a list of names and I'm having a list of friends, and then I wanted to compare them. Although we could do
oh,
it,
okay,
we
I
could
didn't
do
do it
it the
that
way
way.
you're proposing.
Yeah.
We could we,
Um,
we we could actually do this, but the thing here is that I'm not checking for repetitions.
Right, right. You're not checking it if it's in your original input dict, and then you're also not checking if it's already
Already in the friends.
in your list of names and friends.
Right. But I actually like the idea that we could immediately go, instead of friends, we could go with missing friends. And then in this case, I would be adding immediately to missing friends, but I would need two conditions. The first condition would be if friend uh, is not in names. So I'm checking whether that friend is in names or not. If
And
friend,
it's not already in missing friends.
yeah, and friend is not, I'm writing this incorrectly and I can't understand why, is not in missing friends names. Why is it highlighting in here? What do you expected? I have what?
Well, I
If you
don't think you
take the
need an
is
is.
out,
Um, get rid of the is. I think you're right
Okay, yeah,
like
is
English,
yeah, yeah, yeah,
but
sorry. You are correct, absolutely correct. I'm trying to write this in normal English and I'm failing.
work on your English, Belyakov.
Yes. So the first check is whether it's a missing friend. So here I'm checking if the friend is actually missing. And if the friend is missing, I'm just checking whether we've already reported that. So I don't want to have duplicate reports of, in this list. And basically after this, for name and image, so I add this, and then I check all of them. Okay, so then, hold on. My question actually becomes, do I need this list? I suddenly realize that maybe I have
Yes,
no
you
need
don't
for.
need the names list. You only need a missing friends list.
Exactly, so I can actually delete this. I can actually delete this, but then here I would simply need to replace names with input dict. I think like this. And I think this would actually work. So I started from one place and then I decided that that's not the best solution. So let's see whether this actually works.
Well, I
The
don't
only thing I need to do, I
think.
need to print.
Oh, right, yeah, yeah. Okay, okay, okay. Yeah, yeah.
I need to print.
I think that would work.
I would need to print missing friends. Let me do one at a time. Let me check. Friend, not an input dict. So unhashable type dict. Not in input dict. Should it be? Oh, okay. Though, no, wait. Do I need to? I don't think I need this. I think it would give me the same result. I remember running into this same error when I was doing this myself, and it took me, a minute to figure it out, and right now I don't remember why this was happening. So one more time for name in input dict. So I'm going. Maybe someone will help me. This is faster. Friend is just the name, but we need the whole dictionary of friends for that person. Okay. So no, hold on. We have for friend here. We have for friend in list of friends. So friend is actually is it iterating over, or is it supposed to be name here? I think that's the issue. Yeah, I fixed it here, but I did not do it here. Yes, thank you. There we go. So at the moment, we see duplicates. So basically we have the correct order, Michael, Koa, Haipang, whatever, Michael, Koa, yeah, but we still have the duplicates. So the reason for that is here we also have to do friend name. Okay. Now let's do this. There we go. 1, 2, 3, 4, 5, 6, 7, 8. And here we have 1, 2, 3, 4, 5, 6, 7, 8. So yeah, in the end, this looks to be the solution, that one of the solutions that we could use. My only question is, I do not remember whether in code in place using asterisks like this was discussed. No. So basically, when I'm putting an asterisk in front of a collection like a list, I am actually, this is an operator which splits this collection into individual items. So this is the same as if I would, it would basically turn in the end into whatever the names are. It would have like Michael, Koa, and all the rest of the names. This would turn into this. So it sort of unwraps the list into the elements of that list separated by commas. So I could have done the same without the asterisk. I would go for name in missing friends, print name. And this would give me actually the same result, I believe. Yeah, there we go. Same idea. I just didn't remember whether this was discussed or not, so let's keep this then as a clear way that everyone should understand of how this works. Hold on one second. I saw a raised hand appear and disappear, and I'm not
Yeah,
sure.
that was me.
Oh, okay, Marcel. Yeah, I see you now. So you have a question or a comment?
Yeah, I have a question in line, what is it, 25?
Yeah.
Why are we using input dict name friends? I mean, we already can we simplify that to what is it, name friends instead of?
Could we simplify it to? But hold on, name is just a string. So if you do you mean like this?
Yeah.
Name is just a string because we are iterating over keys in input dict. So inside name, you would get first this string, then you would get this string, then you would get this string. And you cannot access a key of a string because strings don't have keys, I think. Let's make sure. So see, it says string indices must be integers, not strings. So it's actually expecting this to be an integer because it thinks you're trying to access a specific index inside the string. Does that make sense?
I'll have to think about it, but I think it will make sense in 10 minutes.
So one more time, let's go
It's actually
through
a
this.
very good observation, because when you're thinking of lists, if you go through lists this way with this statement for name in a list, you get the whole information in that name, Everything that's there, you get in a list. But in a dictionary, you only get the key. And if you want whatever's under that key, you need to use that construction and
Okay.
actually say, I have the key now. Let me get everything under there.
Hmm.
Yeah, so basically in our case, name would iterate over, Caval, whatever the second name is, whatever the third name is, etc., etc. So these would be the values that are stored under name and not the entirety of the key value pair.
Yeah, I see. I see. Mm.
Yeah.
So,
You-
Thank you.
Alex, can I ask you just to maybe walk us through what what each of these variable actually holds?
Okay.
Just like okay, and so in line 24, right? Name is a user-defined variable that
Yes.
refers to the key. And so name would just like you said, hold like Havel and all of those funky names, right?
Yes.
Okay. And then if you go to line 25, okay.
Hmm.
And so when you have the input dict name, friends. Okay, this gets to those pink names that's in the JSON file. Like d- uh right, like these gets to the dictionary that holds like, Brandon, Salvador, Eugene, right?
It holds the dictionary which holds both the name and the
In the years.
years.
Okay.
Yes.
Okay. And then here, friend is again a user-defined variable,
Yes.
right? Um,
Yes.
and so and so friend, can we see that JSON file again, please?
Sure.
And so here friend, I'm trying to figure out what does friend refer to here?
I'm
Um,
highlighting what friend refers to.
okay, and so friend refers to that. But the friend is a key, right?
No, friend is not a key.
Oh, friend is not a key here.
No, it's like you said, it's a user-defined variable.
Okay, and so it's a user-defined variable. Okay,
I could have
uh,
called it anything. I could have called it X.
okay, and so, um, but friend holds a dictionary.
Friend holds, yes, it
Okay,
iterates over these dictionaries. So in first iteration, it holds this
okay,
one, second
okay,
one, this one,
okay.
third one,
Which
this
is
one.
why, you could get the name of the friend by associating it with the key name.
Yes, exactly.
Got it.
We could have simplified this a bit because I didn't realize this mistake that I made previously. We could have done something like name equals friend name, and then I would just
Yeah.
everywhere use name like this.
Yeah, that's what
Well,
I
no,
did.
this is a bad idea because I think we would duplicate this. So I would say maybe friend name equals this, and then would go friend name here, friend name here.
Specific name, comma, he could try either his primary care provider or see if there is a psychiatrist in his insurance
Sorry,
network area.
MC, we can hear everything you're saying. Your mic is on right now. Yeah, there you go. So this would give us the same result. It's just one extra line to get this value. Okay? Like specific name of a friend from the dictionary above.
Just one comment, because when I look at these like multiple levels of nesting, it reminds me of those like stackable Russian dolls. I get very confused, I think it helps to write out, what the variable is referring to, and what that data structure is. So, if that helps anybody.
Okay, good point. Anything else? Any other questions, points of discussion on this one? There was actually an interesting discussion which we had in the completed room, because one idea popped into my mind, and it actually deals with sets. Sets are another data structure which was not discussed in Code in Place. Basically, a set is a data structure that has values that do not repeat. So you cannot have multiple values of the same value in a set, if you know what I mean. This is close to sets in mathematics, if someone, had any experience with that. And the interesting thing is that you could actually have a set of all friends. You could have a set of friends, you could have a set of names in the dictionary. You could have a set of friends mentioned, and then you could compare them and subtract one from the other, and you would actually get a list or a set of people who are not present in that dictionary. So this is another solution which could be done, which is completely different from the one we're doing here, but it was an interesting discussion. And I see, like, Flora, you're right now writing, this was my solution with sets, so this can actually be done with sets. Exactly. So you have the mentions, you have the people, you subtract one from the other, and you basically get the result. So kudos on actually using that. I like that solution. It's a very different solution, but I like it as well. And I wouldn't be actually surprised if it's a faster solution, because sets work very quickly, and we would not have these loops inside one another, which make actually programs run slower. Okay, so shall we then go into the next one? We have half an hour. I actually think that the second one is a bit easier than the first one, although I could be wrong, but let's see. So let me share my screen once again. This one is called cryptography. Can you see my screen now? Okay, so with cryptography, we're supposed to implement a couple of functions. The first one is called encrypt, and this function will take in a plain string, so just text, and it should return an encrypted string. And when we say encrypted string, it has all of its uppercase English letters replaced by other uppercase English letters according to a JSON string, which actually contains a dictionary with the letter pairings. So this dictionary this letter has to be substituted for this one, and this one for this one, etc., etc. So at the end, you have to, this function has to return an encrypted string. And the second function, which is paired with the first one, is called decrypt. It takes an encrypted string and it has to return a plain string using the reversed version of the dictionary discussed above. So a very simple example, for instance, if we say print encrypt hello world, using the dictionary that we're provided, hello world will be turned into this string, kuvaks, and then if you use decrypt with this string, whatever, you would get back hello world. So it should work, both ways and produce the same result. So whatever was entered into encrypt should be the return value of decrypt for the same encrypted message. Klingon, it does sound a bit like Klingon, I suppose. Why not? So that's the assignment. Does anyone have any questions on this assignment? Or shall we dive right in our rooms? Hold on one second. I did not get that far with my homework.
That's
okay.
fine.
Well, you'll be able to think about it and discuss it right now.
Okay.
So hello once again. How did it go, Dieter? How did it go with your group?
I think, well, we did the encryption, and we
Okay.
successfully passed all the tests there.
Okay.
And we just started to discuss how would we invert the lookup table, the dictionary.
Okay.
So that's something we haven't really discussed.
Okay, but that's actually the only thing you would have need to do, because decrypt is criminally similar to encrypt if you look at the function. And we're discussing with the guys that there is actually no need to have two functions because they work almost the same. You could do the same by just providing a second parameter to that function, like what is the dictionary that you want to use for either encryption or decryption or whatever. But we can discuss that right now. Okay, so we have 13 minutes to take a look at, once again, I will say a solution, because the number of solutions for this assignment is probably close to endless. So first I would need to load this JSON string. So I don't have a file, I have an actual JSON string. I need to load it into a dictionary. And the way I do this is use the JSON module. And the method I need is loads.
I can't see your strings.
Sorry, I forgot. Thank you. I forgot to share. Is it okay now?
Yes, thank you.
Okay, cool. Thank you. So now the method is not load. We use load for files, but we use loads for strings. And my guess is that loads actually stands for load string. That would be my guess. And then we just need to pass the string, I think, which is this one. I believe this is the way it works, but let's check, because I can sometimes be wrong. Let's just print this out and see what it actually prints out. Yeah, that's what I'm looking for. So now that we have our encryption dict, we can actually immediately create the decryption dict. So let's have both dictionaries available to us at the same time. Let's say decryption dict. So this is something, Dieter, that your group was about to discuss. And I would actually create a separate function. So I would do a function like create decryption, dict. I could actually pass the encryption dict as a parameter in it. So let's write this function. How would this actually work? Create decryption dict, and here I would say, I don't know, dictionary. Some sort of dictionary is passed in. So basically, if this is the dictionary that I'm working with, the thing that I need to do is to switch the key and the value places. And this is a bit dangerous because, as it was talked about in the lecture for this session, if you have a dictionary where you have different keys which actually have the same values, there is a dilemma. How do you reverse that? So for instance, if I had T here as well, like if I had this, then if I were to reverse this, what would be under the key T? Would it be only A? Would it be only B? Would it be both A and B? So that's a dilemma. But in our case, the thing that makes it easier is that, sorry, what's going on? Okay, there we go. What makes it easier is that we know that each of the values here is unique. So we know that there is no doubles, triples, whatever in the values. So this makes our life a lot easier, because the thing that we need to do, we need to create some sort of decryption dict. Initially it will be empty, and I would go for key comma value in dictionary items, if you remember, we can use the items method to gain access to both the key and the value in our iteration. And then the only thing I would need to do is say in the decryption dictionary, under whatever is value, I would want to store the key. So I'm basically swapping the value and the key, I'm swapping places, and at the end I just need to return the result of this function. So once again, why is it yellow? Is not defined. Oh, okay, of course I need to define it before I actually do this. That's quite logical. We don't have a main function here, so that's why it's not happy about it. Or we could actually do a main function. Let's do a main function and keep the constants above. So I will do main, and we'll write something here, and then if main equals main, we will launch main. And here we will do, we will like result equals encrypt, let's say whatever, this is an important message, and then we would need to print the result of actually decrypting whatever we get here. And then the result of this would supposedly be the same message. We could actually print the encrypted message to see what it looks like encrypted, and then what it looks like decrypted. And now, no. I don't think we should have any problems. Should we? Just give me a sec. I'm not sure why it wants me. Oh, okay. Yeah, sure. I understand why it does this still. Okay. Let's place it here. So we have now we have a function which gives us the flipped dictionary. Now the only thing we need to do is do the encryption and then do the decryption. The decryption will use the absolutely same algorithm as the encryption here. So it's going to be the same function. So the first idea that comes to mind, if we need to return a string, which is going to be the cipher text, for instance, cipher text, let's create an empty string. We will perform some actions to fill that string with, encrypted letters, and then we will return it. So how would we fill it with the encryption? So we would go for letter or for character, whatever you want. It's not, sometimes it's not a letter, so let's go with symbol, for instance, in plain text. We would actually need to check whether that symbol is one of the symbols which are given to us as keys here, because remember, our messages could consist not only of letters, but also of white space, punctuation marks, etc. And those need to stay as they are without any changes. So in our case, we need to make check the condition. We're saying if symbol in our encryption dictionary. In this case, we would do cipher text plus equals whatever's in the dictionary under this key. Otherwise, we would simply add the symbol itself without changing that symbol. And this should provide us with the necessary result, but we can also always check. So as you see, upon running the first function, we get this, which looks very similar to what we would expect. So we're saying, I forgot what we're saying. This is an important message, so this is supposed to be this, VKBS. Let's check. T is V, H is K, so VK, yeah, it looks like the correct B, and S. S is actually S. S doesn't change. Okay, so the first function works. And now the only difference between encryption and decryption is the dictionary that we use for this change. So I could take this, I could actually copy place it here. It would be more logical, instead of ciphertext, to here call it plain text. And here it would be ciphertext. So we just change the, is it like this? No, it's with I. So if the symbol is in decryption dictionary, we add to plain text whatever's in decryption dictionary under that symbol. Otherwise, we simply add the symbol to the plain text and we return the plain text. So basically the only thing I did is flip plain text and ciphertext, and instead of encryption dictionary, I now have decryption dictionary. And we should get the result we're looking for right now. So one more time, we have the encrypted message and we have the decrypted message. So this works, but as we were discussing in our group, this is not the best way to do it. And the reason why this is not the best way to do it, although it's a good way to do it, I mean, it solves the problem, but it does not solve it as quickly as we could have done. The reason for this is that we're working with strings. Can someone remind me, are strings mutable or immutable?
Immutable.
They are immutable. So what does that mean, Vicky, when we do this? When we actually try to add something to a string? What does that actually do?
Creating a new string.
There you go. That's exactly what's happening. So imagine you have a text that you want to encrypt that has 10,000 characters in it. How many new strings would you create in the time that the program runs?
10,000 new strings.
10,000 new strings. And you could guess that probably creating a string is somewhat, it takes up resources of your computer.
Who cares about resources? I just want it to work.
Yes. So, however, we have some mutable data types which are faster to work with, because instead of creating something new, they simply add to something that's already existing in memory. So yes, Mansi, the idea, it's a very good idea. We could actually use a list instead of a string. So here, instead of ciphertext being a string, I would create an empty list. And now, instead of adding something with the concatenation symbol, I would append to the list. So this would be one, this would be another. And the only difference is I do not obviously want to return the list. So this would be a list of symbols. I need to turn this list only once and create only one new string before returning it. And the way I do it is by using the join method on the list. So this one, I think this was discussed in Code in Place, but it's a bit of a difficult method because you sort of don't understand why are you using a method after an empty string. So this is a bit backwards. But the idea here is the following. You say, please take this string and join the contents of this list together using this string as the separator. But in our case, we don't need a separator, so that's why it's an empty string. We could have done something like dash, and then we would have had dashes. I can actually launch this, and you would see that, the message that you have actually has dashes in it, but we do not need those dashes. We actually need nothing between the elements. So if we run it now, you see we have the correct solution. but this would work a lot faster than the previous one. And the same would apply to decrypt. We would have a list here. We would append here. And we would append here. Oh, sorry. Append. I deleted too much. Symbol. And here we would also need to do empty string, join plain text. So visually, you would not see a difference. The result that you're getting would be the same, and you would say, Alex, why are we doing this? But if you actually take a long text like Tolstoy's War and Peace and you decide to encrypt it, the second one would be a lot faster than the first one. It would be very noticeably faster. And that's the reason why, as a programmer, at certain points in your life, you start to think about optimization. What are not only the correct way to solve a problem and to get the correct result, but actually the optimal way of solving this or that problem. And this is where something called asymptotics comes into play. So basically the speed with which your computer solves problems. It's a very interesting topic. I know Vicky had a discussion on it. It's called the big O notation. That's the one. This applies directly to what's happening here, I think. But it's a separate topic. It's not an easy topic, so we're not going to discuss it right now. Moreover, we're already 3 minutes over our time limit. So the thing that I want to ask, whether anyone has any questions or comments on what I've done with this second one. Okay, Flora, I see you through your solution. So you are using a dictionary comprehension here. So basically, yeah, you're doing the same thing I'm doing through a function. You're doing it through a dictionary comprehension, which is just one line. So I like that solution. We have not discussed comprehensions yet, but it's a good way to do this. I like it. So then, yeah, the rest is the first solution that I did with the string. So keep in mind that actually using a list here instead of a string is a good way to speed up your program. Any other thoughts, questions, comments?
If I could just make one announcement, okay.
Sure.
First of all, Alex, you finished under record time. This is like a record, you know. You actually did not go over by that much. You're like learning. But for next week, okay, I just wanted to remind people, I'm sorry, like basically Alex and I, we both had work-related scheduling problems. And so we had to move the session once again. And so it is not going to be on Wednesdays. We're actually moving it to Friday, October 3rd. It's been changed on the Google Calendar and also on the schedule on the main forum if you subscribe to the Google Calendar. I will also send out an announcement to that regard. But just don't show up on Wednesday because nobody's going to be here. But you could show up to Dieter's office hour on Wednesday night. And then, you know, so far for the last 2 weeks, it's just like Dieter, Nick, and I, and then we have a ball, and then I learned a lot. And so, you know, you're welcome to like join us. And I promise it's not going to be a 4 or 8 hour session. It's only 1 hour. And then we talk about a ton of stuff, ton of interesting stuff.
So everyone is welcome. Where can we see?
Are the office hours for this assignment specifically, or for
Office hours is for
No,
anything.
it's office hours for anything you want to discuss.
You can talk about like the
Python
meaning
related.
of life. You know, we talk about politics, we talk about food, we talk about wine and cheese and gaming, and Big O and hashing. And then what else do we talk about,
So
dear?
you have Big O and hashing somewhere between food and wine.
Yeah, I
Yeah.
think that
Yeah.
covers about it. Emma also has office hours, and I guess for Europeans, she's in a more appropriate time zone. Her office hours.
Yeah. Okay. Thank you.
Um,
So
I mean, they could also help you with past assignments too, or like future assignments. I can't help you with future assignments because I don't know that much, but the two of them like know just about everything there is to know.
Oh
Um,
yeah, just a short note on the bajillion assignment. When you use sets, I thought, oh, I can use sets for this. The doc test doesn't work because the result is a dictionary.